Hello, my name is Sandip Gautam, and this is my final project presentation for the course Software Quality Management at Lute University. In this project, I carried out a quality evaluation of an open source software project, Apache Daffodil version 4.2.0. Over the next 15 minutes, I will introduce the project, explain how I carried out the evaluation, describe the problems I faced, I'll present my finding, share what I learned, and finish with 10 suggestions for performing quality assurance in software engineering. As this was a solo project, I completed all the work and all quality assurance role myself. Let me start by introducing the project. Apache Daffodil is an open source implementation of the data format, description, language, usually shortened in DFDL. Mm, DFDL is an open standard for describing the structure of fixed format and binary data using a scheme. Daffodil tags use a scheme together with some input data and process that data into a digital logical structure called an info set. The info set is most commonly converted into an XML or JSON. So, existing XML and JSON tool can work with data that was originally in a fixed or binary format. Daffodil can also do the reverse operation called unparsing, which takes an info set and write it back into original data format. In simple terms, Daffodil is a translator between rigid, low-level data formulas and low-level data formats and modern, easy-to-use formats like XML and JSON. This is very useful in areas such as defense, telecommunication, and scientific data. And in any field that still relies on legacy or binary formats. The project is mature and active. It is written mainly in Scala with some Java and C. It is organized into several modules such as core engine, the command line interface, and Oxy code generator, and it is built and tested with the SPT build tool. I selected Daffodil because it has clear, well-defined job, which makes it quality easy to reason about, and because it has a very large existing test suite that I could evaluate. The goal of the project was to evaluate the quality of the software, not to change it. The assignment asks for two separate documents. The first is test plan, which set out the strategy, scope, methods, and tools for testing and justify those decisions. The second is a test summary report, which presents the report of testing and proposed quality improvement activities. My objective were therefore to understand what Daffodil does and what risks it carries, to define a sensible testing approach for it, to evaluate its existing quality using its own test suite and tools, and finally to recommend ways its quality should be improved. I treated the project own test suites as a main expression of how the software is supposed to behave, and I have assessed the project against the ISO 25010 software quality model. Now I will tell how I carried out the project. Uh, now I followed an informal but structural process. First, I studied the project, reading the documentation and source code to understand what Daffodil does, how it organized into modules, and how it is built and tested. Second, I identified the product risks for a data parser. The main risks are incorrect parsing, deviation from the DFDL specification, fail to reproduce the original data after a parse, and unparsed round trip, poor performance or high memory use on large data, weak handling of malformed input, and differences across operating system and Java version. Third, I designed the testing approach in the test plan because Daffodil behavior is defined by clear inputs and outputs. I made black box functional testing and primary method uh, using the project test data markup language or TDML. Uh, in TDML, each test case provides an input and expected info set, and the actual output is compared against it. I complemented this with the white box unit testing using JUnit and scalar test, and I planned smoke integration, regression, and performance using as well, testing as well. Mm, Fourth thing is I evaluate the existing quality. I measured the size of the code base and the number of tests case directly from the course. I examine the test results in the line with the project continuous integration, and I look at the project coverage and static analysis situation. Uh, for tooling, I use the project own quality tools because that gives result that match how the software is really built and verified. This include SPT as the build and test runner, JUnit and TDML for the test, S coverage and Code group for coverage, uh, and Scala FMT for code style, Apache Rat for license checking, and GitHub Action for continuous integration. And uh, for testing for testing execution and results, let me now present the results which are hot of the test summary report. The first things that stand out in the scale of the test suite, mm, measured directly from the 4.2.0 source. The project contains 8433 partial test cases and 1252 unpartial test cases written in TDML, which is 9685 functional code cases plus 6833 unit test methods. This is total of more than 16,500 defined test cases supported by around 67,000 lines of test code against roughly 118,000 lines of main code. When I look at the execution outcome, the active test suite passes, which is consistent with the project continuous integration on its main branch being in a green passing straight. Of the defined tests, 126 are explicitly disabled in the source using the ignored annotation, so I reported those as skipped, and no failing tests were found for the evaluated baseline. In percentage terms, about 99% of the tests pass and less than 1% are skipped. The tests are concentrated in the dedicated test module and code engine, which is exactly what you would expect for parsing library, and the project measures code coverage with S coverage and publishes through core code on every build. Taken together at the large parsing suite and the published coverage, so that the core parsing and unparsing logic is very well exercised. And then static analysis and quality assessment. Alongside running the test, I look at the code statically using the ideas of code smells and technical depth that were studied in the course. I searched the source for the common technical depth markers and found 162 comments and 26 fix me comments and no hack comments at all. Uh, for a code base of the size, this is low and well managed level of self-identified technical depth. And I then rated that project against the ISO 25010 quality model. Functional correctness is strong because the very last passing test suite verifies behavior against the DFDL specification. Reliability is strong given the mature code base and the green continuous integration history. As you know, maintainability is strong, held by enforced formatting a modular structure, and low technical depth. Portability is strong because the project is continuously tested across Linux, MacOS, and Windows on more than one Java version. Performance I rated as adequate since the tool is built for streaming data, but I didn't run a separate benchmark, and security I left as not assessed because it was outside the scope of the evaluation. The problem that I faced during the projects uh, was the biggest challenge was the size and complete complexity of the project, with well over 100,000 lines of course across many modules and a heavy Scala and SPT build. It was not practical to build and run the entire project on modest laptop. I dealt with this by analyzing the source directly for the measurable facts, such as the trace count and technical depth markers, and by relying on the project public continuous integration as the baseline for the pass and fail outcomes. The second challenge was unfamiliarity. Daffodil is written in Scala and DFDL standard and TDML test format were new to me. I had to spend time learning the domain before I could evaluate it meaningfully. The third challenge was deciding where to focus. With more than 16,000 test cases, I could not inspect everyone, so I used a risk-based approach and concentrated on high criticality areas and the modules that carry most of the test. From all of these, many main findings are as follows. Apache Devotel 4.0 is a mature, high-quality project. It is backed by an exceptionally large and well-deserved test suite. It is continuously built and tested across several formats and Java versions, and it applies automatic styles, license, and coverage checks as a normal part of its process. I also found areas that could be strengthened. Most of the functional test cases sit in a single large test module. Some smaller modules such as C code generator rely almost entirely on TDML cases and have very few unit tests. The project doesn't appear to run a dedicated continuous static analyzing tool such as Sonat Cube, and what I learned from the project is, on technical side, I learned what DFDL and Daffodil are and how data transformation can be tested clearly using input and expected output test cases. I also saw how a large professional open course project actually manage quality in practice with continuous integration, code coverage, and automated style and license get working together. Uh, Most importantly, the project reinforced the central lesson of the course, which is that quality is built into the process, not simply tested at the end. Uh, and I also saw the technical depth and code small ideas from the lecture appear in real code base, which made much more concentrate for me. Well, with less time remaining, I will tell the 10 suggestions for quality assurance. One is build quality in from the start, apply quality assurance across the whole life cycle rather than relying only testing at end. And second one is automate testing and run it continuously so that every change is checked automatically through a continuous integration pipeline. And third one is measure code coverage and set a minimum threshold, paying special attention to error handling and edge case path. Fourth one is use static analysis tools such as SonarCube to detect code smells, bugs, and security sensitive patterns early and objectively. And fifth one is track technical depth, for example, by monitoring todo and fix me markers and pay it down regularly before it grows. And sixth one is enforce coding standard and formatting automatically so that style stay consistent. And seventh one is use clear well-defined test cases with a well-known expected result, which makes failures easy to detect and understand. And eighth one is test across all target platform and environmental to make sure the software is portable. And ninth one is manage the effect properly, recording each one, classifying it by and tracking it through to closure. And last one is foster a quality culture where the whole system shares responsibility for quality and users reviews, inspection, and continuous improvement as everyday practice. Just with short summary, and thank you. Conclusion, I evaluate the quality of Apache Daffodil 4.2.0 by producing test plan and a test summary report and grounded in the project, well suit and tools. I found it to be mature, high quality project that passes its for active test, carries low technical depth. Thank you.